So if we talk about no-till production, especially in organic, then this is really a very high-end method. So it's quite difficult to approach a completely no-till, have a completely no-till approach in arable field farming, in organic agriculture. But rotational no-till is definitely possible. So we did trials and we worked for 4 or 5 years with the roller crimper method in spring, like Jeff Moyer from the Rodale Institute developed this system. So what you do is you seed a cover crop like rye, for example, in September, beginning of September, for example, and then you develop the cover crop over the winter, and then in spring you don't terminate it, but you wait till it grows up and starts flowering. And then when it flowers, you roll it down with a roller crimper. That's a tool, it's a drum that is mounted in front of the tractor. You roll the cover crop down, and at the back of the tractor you already have your seeding equipment. So you roll the cover crop down, you create a mulch layer, which should be so dense that you cannot see the soil anymore. So you roll that down, you crimp it every 20 centimeter, like which is done with this drum in one process. And at the same time, you seed your cash crop into the created mulch, which could be soybean, for example. So that's a method that's proven all over the world and works quite well. But there are some disadvantages with this method, and in our case, it's too difficult to do it in most of the years. Not in every year we were successful, but sometimes we were not successful. The reason is that you come in late with your cash crop because you have to wait till the rye starts flowering. Otherwise, when you roll it down before it starts flowering, it starts to regrow because the plant knows it didn't fulfill its function, and so it starts to regrow, and you end up with rye as a weed. So in our case, you come in with your soybeans like end of May, beginning of June, more end of May likely, but that is already a delay of 3 to 4 weeks with our normal standard soybean seeding. So that's a disadvantage. The other disadvantage is that we have very often here in this region, we have spring drought. So we have too little rain over the winter, and especially then in the spring, it's very dry here. And what happens is the rye needs to produce this amount of biomass, and we're talking here about 7 tons of dry matter, straw. To produce this amount of biomass, it needs a lot of water. So we digged it up, and we recognized that the soil is up to a depth of 1 meter or 3 feet, it's dry. So your cash crop that you put into this dry soil has to receive some rain, otherwise it doesn't work. So these are the 2 main disadvantages. What we did is now we did some trials together with a colleague, Peter Falb, and you can see the video here now, that we did try this method not in spring but in autumn. So what he did is, you can see the fava bean cover crop, which is rolled down again with a roller crimper and attached to the tractor a seeder. So you can see that instead of applying this direct seeding method, organic no-till method in spring, we applied it in autumn, and we seeded winter wheat, and this worked out very, very good, and it's a very promising method in my opinion, because you get rid of these 2 disadvantages. You get rid of the disadvantage of late seeding, because you can still seed the winter wheat when, like, mid of October here in our region, so that's not a problem. And because the cover crop, when it flowers and you roll it down, it's killed. If it doesn't flower and you roll it down, it's killed by the frost anyway. So that doesn't really matter. and then you do not have the competition for water, because the winter wheat doesn't need a lot of water. There is enough water to germinate for the winter wheat and to develop into the winter, but it doesn't need a lot of water, and during winter the water body should be refilled easily, so the winter wheat can start in an early season. So you see, there are these different methods of no-till, and I'm talking about the organic no-till roller crimper method here, but we also apply other methods of no-till. So for example, when we seed lucerne alfalfa, then we seed it together with the last crop, like oat or barley. So we seed that together. We can seed in one pass 2 different crops in 2 different seeding depths with our machinery. We have a Federstad Rapid with a grass seeder box attached to it. So we seed in spring, early spring, we seed the oat seed in 3-4 centimeter depth, and then at the same time we seed the lucerne on the surface of the soil, and it's just distributed through the harrow that runs behind the seeder. And then what you do is, in summertime, when the oat is mature, you combine the oat, and then the alfalfa, which germinated in spring but didn't develop very good because the oat gives a lot of shadow, so the lucerne struggles a bit below the oat. But the shadowing of the oat also makes sure that the lucerne can germinate, because it's more moist in this area where the oat is shadowing. And so the lucerne can establish but doesn't overgrow the oat. And then when you combine the oat, the lucerne gets air, gets room, and then it starts growing. So that's also a method to apply no-till, to apply no tillage between 2 different crops. And what we also do is, after combining like wheat, we try to reduce if we have clean fields, we do not till, but we immediately seed the cover crop, slice the cover crop without tillage into the ground, and so reduce tillage. So overall, when we consider the crop rotation of 8 years, we are in about 30% of no-till right now, and we try to improve. We try to do more in case of mixed seeding, and see if we can use living mulch. But all of these topics, they are still something that the research farm has to do more and has to put more workforce in such methods. When we think about reduced tillage and no-till in arable field farming, we have to think about compaction. To reduce compaction on the field, on one side, you should go with your small tractor on the field as much as possible and not with your heavy equipment. But then you can also adjust the tire pressure, for example. A very simple method and pretty cheap. So this equipment is 250 euro per the whole system for the tractor, is this system to adapt the tire pressure. So this is a very simple tool to use. You just, what you have to do is you have to change your tire valve, which is very easy. You don't have to remove the tire or anything. You just remove the old valve and screw in the new one. And then you just put this measure on it. And then you can see here the amount of tire pressure. So it's 0.6 bar right now. We only work between 0.5 and 0.6 bar on the field. And if it's too much, you just turn on that valve, turn it on, and the air comes out. And if you have too little, you plug in here a hose, which is either connected to the air compressor in your shop or to the air compressor on the tractor. and you turn it on again, and then the air flows back into the tire. So adjusting the tire pressure, like removing the air, is like 1 minute per tire. Pumping up with a compressor in your shop takes maybe 2 minutes per tire. And that's a very easy way to reduce the tire pressure. And you have to consider if you have 0.6 bar in your tire, then you also only put 0.6 bar on your field. So what you do is you increase the surface area of the tire, so the weight distribution is much better. And what you also do, you have to know every centimeter you sink into the soil is like driving against the slope. And every centimeter you go into the soil gives you 10% more diesel consumption. Every centimeter. So avoiding this through higher surface area really helps you to reduce your fuel consumption, and at the same time reduces the compaction on the field. Putting in 0.5, 0.6 bar with an equipment, a tillage equipment that is attached to your 3-point hitch doesn't make sense, because when you lift your equipment, then you have a lot of load on your tire. Therefore, we use equipment that brings its own trailer, and I'll show you some of this. So the typical kind of reduced tillage that we conduct is with this tool. It's a Trefler Präzisionsgrupper, and we usually till only 3 to 4 centimeter, which is about 1 to 1.5 inch deep. And what it does and what it enables us to do is to drive the tractor with very low tire pressure, because with this hydraulic system, it pushes down at the end of the field or on the road, it pushes down these wheels, and then most of the weight is carried by these tires and doesn't have to be lifted by the tractor itself. So that enables us to go with a lightweight tractor, to go with little air pressure. What it doesn't help if you have a contractor with a combine and you have a big combine, it still have problems to again compact the soil, especially with corn, where you are very late in the season and probably quite moist like right now. But this is one of the reasons why we stopped growing corn on the farm. One reason was because we didn't want to support livestock fodder, produce livestock fodder, but more human food. And on the other side, corn is quite good in profits, but not so good considering late harvest, and therefore probably soil compaction on one side, but also no possibility to grow a cover crop after corn also. So this tool, it has goose feet tiles which overlap like 8 centimeter. So it makes sure everything is cut, and we also terminate lucerne with it, 3 to 4 centimeter deep. So we do not have to plow the lucerne to terminate it, but we only cut it like 3-4 centimeter, and that kills the lucerne very efficiently. That works very well. And we are quite happy with this tool, even if after about 8 years of use, now we did trials with a subsoil ripper to lift a bit, break a bit the compaction in the soil. We will see how that works out in the future, if this will be a solution to say, okay, we keep up with reduced tillage, but then every 10 years or so, or every 8 years, we go with a subsoil ripper. Let's see how that develops. Still a lot of research needed in this topic. What we can see here is that there is a lot of straw, because the crop here was a rye crop. And if you go in here,
you can see a lot of earthworm activity. So we have one earthworm here, another one on there, but here it's 2, 3 earthworms, 4 earthworms. So there is a huge amount of activity coming from the earthworms. A very good activity, a lot of holes, a lot of earthworm burrows, which is important. But still, you see the tilled area is very soft, very crumbly, very good aggregate stability. But then there is a chance that we get a little bit of more compacted soil, and therefore the discussion is if it's necessary to, if we should do some subsoil ripping. So you can see there is a difference. Again, heavily penetrated by earthworms, a lot of young earthworms, and therefore we want to avoid too much tillage. But then question, still smells very good. But I would love to see more this loose area like it is in the top area, because there you see much more roots, much more root activity, and even more earthworms, as you can see. So no lack of earthworms because we implement reduced tillage, but still room to improve. And this is what we actually want to do with the concept of the research farm. So we apply methods, and then if we see room to improve, then we ask scientists to come in to join us, and agronomists, laboratory, and see, okay, where can we even improve, where can we do better, and where sometimes we even have to change our methods and adapt them to certain situations. And this is really something that we want to do, that we want to work on, to get better with the time, to learn more about how to grow, how to manage the fields, how to manage the cover crops, which species, and so on. So a lot of earthworms, a lot of good things, some things not so good, but we are a research farm and we have to improve.